Hey guys, good morning. It's Mr. Zimmerman, and today we're going to mix up the operations between converting between exponentials and logarithmics and back and forth. So this is the third video in the series, and we're going to go ahead and talk about mixed operations where I have to convert between forms, and then we're going to go ahead and talk about common logarithmic forms that you're going to encounter. So team, basically we've been practicing and we're going to finish up this chart. We're going to go ahead and start on the left with e to the x is equal to 24. And I'm going to go ahead and write this as my exponent. What is my exponent? X equals log of my base, which is e, to 24. Okay, and I'm going to do that again. Okay, my exponent is equal to the log of my base of my output, x. Okay, voila. Looking at the right, I see log of 7 of 10. Right away, I see that my brain does not have a number. So I am going to assume that is going to be log base 10. So now I'm going to write it, my base, 10 to the x is equal to 7. Which form is more useful? I'm going to definitely say this guy, because this is going to actually give me a value for x. I'm going to go ahead and jump down to the next one. Whoa, ln. Well, from last time, we know ln has a base of e. So when I'm writing it, it's going to be my base to my exponent is equal to x. Here, this form is going to be much more useful. I have a way to generate x. In the other form, in logarithmic form with ln, it's going to be a little harder to determine what x is. All right, this next guy, my base. What is my base? Okay, since it's ln and not log, I know to assume that it's base e, and I'm going to raise it to my exponent, and it's just going to equal 77. Now here, this case is going to be much more useful because it at least lets me generate x. Notice how in the cases where I would not care to use it in an exponential form, the x is in the exponent. That's what's making it so difficult, and that's why we had to invent the logarithm. Now, we're going to go ahead and talk about natural logs, ln of e. So over here at the bottom, basically what I'm saying is that if you see log, what this is communicating is log of 10. And if you see ln, what this is communicating is that it's log to a base of e. It's called the natural log because although you don't think e is natural, e is like 2.71 something. It's the same as pi. And these are actual numbers that aren't made up. They are naturally occurring. They're kind of like asymptotes where you approach, but that's why it's called natural. I know it's definitely not natural to you. Really though, just remember when you see ln, it's talking about e. And one way I remember Ellen, the TV host, starts with E. If that helps, whatever gets the job done. I do want to point out, though, that in both of these examples, I can actually clean up my algebra a little bit. I can rewrite this to be x is equal to ln of 24. And you notice how the base disappears? Well, that's because when it's in ln form, it's log of e. So that's a little bit cleaner. And whenever I have an opportunity to clean up, I always do. I'm going to do the same thing for this guy. 15 is equal to the natural log of x. And this is communicating that it's e to the 15. Now, I definitely know that this form is much more valuable. The reason being is that I can generate the value of x. I can type e to the 15 in my calculator, and it will go ahead and give me a number.